Hi everyone. Reaction of alkyne. Well, reaction of alkyne is really the same thing as reaction of alkene. Okay? The difference is triple bond versus double bond. That's it. Okay? So all the reaction that we saw, the other days with reaction of alkene can be applied to reaction with alkyne. Okay? So let's do a few examples so you guys understand exactly what I'm talking about. I think we first had dehydrogenation or something like that, right? Dehydrogenation of alkane. Okay. Now, if we were to do dehydration of alkane twice, you will get an alkyne. Now, let me just tell you exactly what I mean by that. So let's say you started out with structural formula this. You have your alkane. Okay, you have your ethane. So you would do your dehydrogenation. So if you remember, in order for dehydration to happen, you need some iron 3 oxide. Okay, these two hydrogen will get together to form H+. As a result, this and this are going to be missing a bond, so they're going to double bond with each other. So you're going to get this. Okay, so you'll get an alkene. So you went from an ethane to a ethene. Now let's say you didn't let this reaction stop. You are going to keep the ball rolling. Okay. This is what's going to happen. These two hydrogens says, since this reaction is happening, we're not being fished out of the reaction vessel. Oh, you know what? Let's get together here. Let me just write this down here. Plus H2. We're going to get together. We're going to make another H2. So what happened? You get this. Alkyne. You see that? So with alkyne, it's really alkene, but more. Okay? More work. Continuing the work. So let's very quickly look at some of the things that we have already looked at before, like halogenation. Okay, with halogenation, we have an alkyne reacting with a halogen. Okay, under 25 degrees Celsius. This reaction will give you an alkene halide. Okay. So what I mean by that is this. So let's say you have ethane again, and you're reacting it with chlorine gas. Okay, that's a halogen. Under 25 degrees Celsius, the two chlorine will break apart. One of the bond in the triple bond will break apart. So you have this. Okay, obviously this carbon and this carbon are missing bonds. These guys are separated. It only makes sense, of course, that this happens. Okay, so just like what I said in the description, alkyne reacting with halogens, you get some sort of alkene halide. Okay. All right. Now, hey, like I said again, this reaction doesn't stop here. It doesn't have to stop here. I can continue. Okay, I can say, hey, let's not let this Let's not let this finish off. Let's put in another halogens here. Okay, let's keep it at 25 degrees Celsius. Let's add another halogen. Let's add bromine gas this time. My, how dangerous this is going to be. I can see I want to get away from this. Okay, so what happened is that this double bond, okay, this double bond right here, this double bond will break. Or this one of them is going to break. Okay, as a result, you get this. This carbon is missing a bond. This bromine gas is going to break apart. So therefore, you're going to get something like that. Okay. So halogenation, going from alkyne to an alkene halide. If there's more, hey, you have a alkyl halide. Just a double alkyl halide if you want to be specific. All right. So yesterday we looked at a very important rule. Okay, we looked at a Markovnikov rule. Hopefully you guys understood the concept of Markovnikov rule. If you don't, hey, drop me a comment. I'll review it with you. Okay. Hey, or you guys can always watch this video over and over again. Just get more ice cream, get more chips. So did you guys ever find out what emas are? Those candies are delicious. I'm gonna get some more. All right. It was something like this. Okay, so I have CH, C, CH3. Okay, propine, right? And I'm gonna react this with HCl. Okay, what am I gonna get? Now, with alkene, we saw that Markovnikov rule applies. The rich gets richer, right? What about alkyne? Does Markovnikov rule applies to alkyne too? Of course it does. Okay? Of course it does. Because if you think about it, if the idea is really the same thing, when this bond decided that I need to break, HCl is here, HCl is broken into H plus and Cl minus because Cl minus is so hungry for electron that it wants to be negative. I'm going to have to do the same. So when this bond decided to, I want to either hang around with this carbon or this carbon, let me see which carbon looks better. Okay, oops. Okay, let's say I want to hang with this carbon. Okay, making this carbon negative, making this carbon positive. Or I can make this carbon negative and make this carbon positive. There you go. The question is this: which one exists? Which one is, I would say, less directly hindered? Well, think of it. Remember, these CH's lies a lot of negativity. Because every bond here, every bond has electrons all over it. And they're all looking towards this carbon and say, hey, how are you doing? Okay, so the middle carbon, okay, has a decision. There's these negative, there's so much negative. This carbon's going to say, well, if I'm positive, I don't mind you guys being here. We'll neutralize ourselves, right? I'm positive. You guys can be all negative all you want. So this situation is a good situation. Whereas if you look at this situation with this carbon saying, here's, CH, lots of electrons hanging around here. CH3, lots of electrons hanging around here. This guy's already negative. Does he want to surround himself with so much negativity? The answer is no. So goodbye. Okay. So for this reaction, you're going to have this H coming over here because positive and negative attracts. This Cl will come over here. Same idea as rich gets richer. But I want you guys to be chemists. Basically, I want you guys to learn something with reasoning, not just because. All right, there you go. Okay, so Markovnikov rule, do continue to apply. So here's an alkene. Can I continue? Okay, can I put like a H2O in here? Okay, and have this reaction to continue? Of course I can. Okay, I can continue. Do I have to follow Markovnikov rule? Yes, you have to follow Markovnikov rule. So, your final answer, if you were to put water in here, will be this. Okay, I'm not going to show you why. I want you to figure out why. Why would OH be attached to the middle carbon and not this carbon? Because when this double bond breaks, OH can be here, right? No. OH cannot be there. Okay? I want you to explain to yourself, like I did over here, like I did last lesson, why the middle carbon gets the OH. Okay. All right. I guess I'm going to leave you with a question to do for homework. And we'll take it up tomorrow first thing. So question 4. I'm not going to write the catalyst. Okay. Okay, I'm done. I want you to tell me what's the real answer here. Okay, so this is actually a little bit trickier than you think, but I think you guys can handle it. All right, I'll see you tomorrow. Bye.